force has both magnitude and direction, making it a vector point.
Okay, guys. Today we start static. And surprise!
Surprise! Relax.
Oh,
Реза не будет.
Нет, it's you may.
Maybe you grade something? It's been 6, 7
I didn't feel great
Ah?
about last quiz.
No.
Oh shit.
Oh shit.
I
Sorry.
checked it.
Sorry.
Oh shit.
Okay.
Where is this?
So today's relaxed time. You may do like this.
Okay.
So yeah,
Chill, just
we don't
chill.
have quiz today because we have a new topic. Yes.
Netflix and chill.
So, as you probably remember, actually, I think that he didn't provide you this slide, yes?
He asked.
That's
He,
even
yeah. No.
What?
He asked whether you provided it.
So he said that I should provide it.
Yes.
Okay, so I am doing it. So, actually, there are 10 possible ways. I had 10 possible. Anyway, let's start to not sleep today. Okay, so there are plenty of them. Actually, I dislike this picture, but I didn't find even better. So let's assume this one. So we have string. It should be attention away from the body to direction of the cable. So we have some body. It's obvious that T should be an upper part. Smooth surface. Normal reaction. Round surface. It contains also a friction. Is the reason why we have two forces, parallel and perpendicular. Actually, not really, because in this case we can remember about a cone of friction, but it's not one topic for you, and probably we'll cover it only on dynamics. I will just provide it to you for extend your horizons. We have roller support. Actually, in our task it will be like this. So it
is the same thing, but in different shape, right?
What again?
Like both of them rollers, right?
Yeah, all of them are rollers, yes. Really sliding guide. So, actually, I will explain today, because we will have task. Fin, just rotation. Built-in or fixed support. This one. Actually, it's better to either print it or do whatever. I mean, it helps if you forget, if you used to forget about it, you can just open it and briefly recap what exactly, what the support provides you, which what forces or what reactions, what kind of reaction. So gravitational attraction and spring. Actually, today I had in my linear algebra class we had a question about, do you know the difference between gravity center and center of mass, and also geometrical center? So we have center of gravity, center of mass, and center of geometrical center. And what the application for this? Do you know?
Geometrical center is for center of mass is the sum of m multiplied by r in a specific point over the whole mass, but center of the geometrical center is related only to the shape itself, no mass at all.
Okay. What about center of gravity?
I'm not sure. It depends on the how the object is homogeneous.
You try to speak too, let's say, too smart. Think, say it in. I mean,
I'm not sure.
okay. Any suggestions? Actually, just again, it may help you because in this case you will better understood what is it, because we used to write.
But is like center of gravity is the point that the gravity is applied on it, right? But is it always the center of mass?
Good question. What do you think?
I think it is.
No. Yeah, not right. Actually, I will open my slides from linear algebra today. is better than when you have it. So for classical mechanics, it's the same. If you want to see a video, I can send it to you. Actually, did you get, because actually it was on statics, if not mistaken. Actually, what's this point? What I mean, what the essence of gravity?
Force.
Yes, but where it is? Where can you apply it?
The
Center of the mass.
Gravity? So I will give you a hint. Do you remember this guy? Yes, and this Fu will be, we just put some point. So what do you think about gravity? Gravity is also a distributed force, but not in the line, but in volume, yes. So actually, your gravity force will be like this. But in classical mechanics, we can assume, and we choose this point. But the problem is that, do you remember that the value of G? 9 or 8. But actually, it's linearization, because we assume that our gravity force has a uniform distribution, not normal, something like this. This is the reason why we can just say, okay, it's the center. If we so assume that we have a, I don't know, steel bar, 100 kilometers length. So we just light it there, and our Earth is a circle. Not circle actually. It's even more. It's a sphere. I forgot. Yes. I forgot how it's called, but actually it's like this. Yes. And your G will change, because assume that it will be like this. And G there and G there will be different. So because of this, our center of gravity for this task will be different between center of mass. Geometrically, yes, correct. But where can it be used? This knowledge. Why do we need to know center of gravity and center of mass? What?
Any real life, like.
So I asking you real applications. Nasa, what do you think? Nasa, you're right.
Building.
What? Why do you need it in buildings?
To build it such a way it will not crash.
Yeah, or maybe
Okay. Any other ideas?
for Earth.
Yeah, what was the question? Why do we need no center of gravity?
Yes, center of mass, center of gravity, yes.
Like model the object.
Monblocks, okay. Where it can be used?
Anywhere, but ballistics, like in army, in space.
Actually, do you
engineering.
remember the control which you had? So you need to make dynamics model. Dynamics model provides you or contains inertia.
Yeah.
Inertia, you can find it according to the center of mass. But the real application, one of the real applications, is ZMP, zero moment position. So we have multi-leg robot, for instance, and we don't actually. If you remember about Boston Dynamics robots, they so it's for statics. I use it in my research. So you can assume that each of your legs which touch the ground provided some polygon. And if our center of mass will be in the center, our robot shouldn't fall. But it will be out of this circle, for instance, like this, and start to fall.
It should be in the center of the.
Not center, it should be somewhere in this.
Triangle.
Is this,
Anywhere.
yes, anywhere inside. In this case, your robot should be stable.
So,
Okay, when we're talking about bipedal robots, because this technique appears for them, because EMP provides you to solve the task not only in statics but also in dynamics. So Boston Dynamics robots have a dynamic. We have static locomotion, semi-static locomotion, semi-dynamic locomotion, and dynamic locomotion. So difference, static locomotion. In each moment of time, I can be stable. So I try to move. It's very slow, but it's easier to calculate. Asimo robot and some. Actually, our robot AR in your lab also has a static locomotion. If you remember the Boston Dynamics robots, they can fall. Why? Because when star move, if we just turn off the motors, he will just fall because his center of gravity not works like this. Is the reason. So in bipedal robot, you assume that your leg is not a point, but a rectangular, for instance. And your polygon will be based on this 1, 2, 3, 4 points. And your center of mass should be in the center. So, see? Our first year bachelors learned this such advanced technique, you know?
So what's the difference between gravity, center of mass?
For classical mechanics, no difference. Because we can represent, as you remember, we represent this one like Q multiplied by L. In this case, it will be, so, G multiplied by volume, blah, blah, blah. You should take integral and so on. And for us, yes, center of mass, center of gravity will be the same, but we are talking about space, spacecraft, and so on. It will be different. If you want to know more, I will send you a link. Just for you, just need to know what it's like. I mean, for your this will be образованный, clever. Okay, you should be clever like a dog. Okay, the first task. The first task. Okay, where is my hierarchy? Okay. Okay. Today we will learn how to write your task and don't receive -2.
That's good. That's good.
Oh, it's already. How many homework passed?
So I told you when we start dynamics, statics is let's say, a part of the dynamics. We will learn how to do it. Okay. So first of all, some hints. It's our task. Absolute rigid body can generate 3 equations on a plane: x, y, and the x torque. All 6 in space: x, y, z, and around x, y, z. Part of the body also can generate 6 equations. So we can divide this body on 2 parts and receive 6 equations. Does it help us? No, because we will have the same, but it might help you in other cases. But you can do it, and you can receive as many equations as you want. Force is an interaction between 2 bodies. It's quite important. So force is, so if we have some external force, it's just external body and your body too. You need to get it because of reaction forces. You need to get how it appears. The third rule of Newton. Okay. The third one. Because we are working with absolutely rigid bodies, point of force can be shifted among the fourth direction. I will explain on fingers. We have a body. I don't know, maybe Kirill explained it to you. If I put the force there, can I say that my force is there? If it's absolute rigid body, yes. In real life, no. Because of deformation. Because if we are talking about material resistance, Sopromat in Russia, it will be on your next semester. You cannot assume like this. Because, for instance, we want to bend something, and this force will be different than this force because of deformation of the material. But in absolute rigid body, you can assume that it works like this. And it will help you in several tasks from the next class, not this class. Today's class is for newbies. Tomorrow class will be contain more.
We can apply on the same line.
Yes. Yes, actually, parallel. No, you cannot say that.
Because torque will be.
Torque, yes, torque can be applied to everybody, to whole body.
And you cannot do it in the parallel line because the torque will
Yes, because you calculate torque according to some. See, yes, actually, it's good explanation. See, we have to. Actually, I will explain there. So if we have force there, we can find according to this one, and we put it there. Our will be the same. No, how can we find this momentum related to point A?
project.
If you use Lemur rule, or forget how it's called, actually to decompose on the basis. Yes, we can either decompose on the basis, or we just need to find intersection between point and the force. So if we put our force there, actually the line will be the same. Torque is any place of the body. You can put it in other places because it's like angular velocity for the body. Actually, we discussed it with Malaleta. He didn't think in this manner, but we figured out that you can do it like this. Actually, you can somehow think about torque. It's like omega, 1 divided by 2 omega, and force. Why? Because momentum for torque equal to force product R. If I talk about angular velocity, it's a bit other story. This velocity equal to omega cross product R. So actually, the mass apparatus are the same for them. I mean, see, angular velocity, we can apply it to the whole body. Torque also can be applied for a whole body.
So you say that
Velocity we also can translate it through the line, as you remember.
So you say that the torque is inverse proportional with the angular velocity.
You can, how say, for me it's not inverse proportional in case of math or something like this. So you have, as I try to make some kind of table, maybe I don't know how to say even in Russian. So I try to connect velocities and forces. Velocity and forces, because it looks the same actually in some cases. So velocity, it have direction and it have some point which apply to velocity. Angular velocity apply to the whole body. Torque also apply to the whole body. Okay, I ask you different. For you, the torque and force and velocity and angular velocity, is it somehow looks alike? I mean, is it? It's completely different.
From the equation that torque is equal F cross product R, and also that inertia multiplied with alpha, the angular acceleration. This is the equation that I know.
I'm talking about, I mean, in terms of under concept, yes. So in terms of math, it should be that in velocity, I mean, we can go from velocity, angular velocity to linear velocity, because angular velocity actually is a pair of velocities.
I mean that
as you remember,
torque shouldn't be inverse proportional angular.
It's not about numbers.
So now I should understand that, right?
See, you have somebody. You should rotate. We can put angular velocity there. So angular velocity. Actually, it's pair of linear velocities. Do you agree with that? We can find this linear. Yes. We put torque there. And also, it's a pair of forces.
Yes.
In terms of concepts, it looks really the same, but not really because we have different equations. I'm talking about this, that you can think it is the same concept. It's like, do you know that you can provide all mechanical engineering part as electrical designing part? And MATLAB, another system, work like this. So you can draw your system like, I mean, like resistance plus, I don't know, this one like spring. In mechanical part, it will be spring, and for you it should be resistance. I don't remember. Do you remember? Damper. Yes, and damper. It will be for, in Russian it's like yeah. In Russian like this, in English I forgot how to call it. So in electronics it will be resistance and conductivity. Yes. But you can use the same. You can use the same. Induction. It's inductors. Yes, inductors. You can use the same figures, and they have the same rule. And in my previous, I mean, in Bauman State University, my faculty made the software for this. So they use the same pictures, but you can calculate different systems: mechanical, electrical, even mechanical plus electrical. So you need, why it works like this? Because everything is electromagnetical. Let's say it's based on electromagnetical.
But they have the same differential equation.
Yes. Yes.
This
Why?
does not mean.
Yes, they have, but Malaritov can explain you that actually because they have one core idea inside of it. So it's the reason why I try to also apply this, let's say, this concept to this place. It's the reason I write like this. If you didn't get it, then actually you don't need it. It's up to you. I just show how I put in my theory in my mind. Okay. So we used to find reactions in our task in statics. Actually, this is on the one question. So if you see that nobody wrote you what do you need to find, actually you need to find reactions. Yes. So we have distributed force L. So our force will be there. It's half. And force, point force will be for L. Also, you may have you can find how to prove it. Actually, for now, it doesn't matter. This one, what?
Concerns.
Okay. Also Q, it will be, now it's better? Not, it seems now. You can prove it, but actually we don't need to do it. And yes, I forgot how it's called, this rule, when you can just make projections, but it has some rule. Actually, it's you just project it on a basis. I mean, we can put P on X and Y direction. It has some rule. Demu, Delu, right? Don't know. So now I'm trying to show on the whiteboard how do you need to solve this task now. And I will downgrade your grades. Downgrade. Your grades, okay. If you want to do it. First of all, you need to write research object. One rigid body.
If we have multiple.
No, we have one body. This. It's our object of interest.
And if we have multiple.
You need to write which, yes. So in this case, we write.
If I solve for system of the bodies.
What?
If I solve some task, like any home task which has system of bodies.
You need to
How
write
is
that
the
you
right?
have several bodies and you need
Several
to.
bodies. You want
Yes,
several
it will
bodies.
be A For instance, I don't know, we don't have B. After this, because now we are not in dynamics but in statics, we need to write body was fixed for A. It's fixed support in A. You also can write it that it will be Rx, Ry, and A. So we don't know what this guys.
said A is what? Fixed support?
Moment.
I mean the word.
Fixed support in A. In B, for instance, the low
What's the
it's way in Russian. Okay. So it will be sliding support, Ry, Rx, oh sorry, and ideal beam. Holding, because I found several notations. It will be Rx. Why? This guy can move like this, but it cannot move upward. So it's the reason why we have direction Y, and it cannot rotate. This one, it can move, but it cannot move in this direction, in X. All these parts you can find on previous slides when I provided. And the last one, B, okay, right in Russian, would be A and B. A. Oh, in A. You may write it as you want. It's 2 sliding. Among X, Y. So we don't know MI. Now we in support. Or hinge. Rx, Ry. After this, okay. Now we can do force analysis. Actually, this approach will help you to get what's going on with your task. Because even now, I can say what we need to find and why it appeared. If you just start to solve this task, sometimes if your task is not so not so trivial as this, it will be tricky. Okay, of course we need to draw the picture. On your sheet, I'll use different not markers and different colors. It will be easier for you. Okay. We need to put forces. Rx, Ry, momentum, or torque, M1K point. We can rewrite this Q in force Q. What else? This P can be divided into two parts. Py, px. Also, we need to know in this case this length will be 5. Now we need to write each force which we have there and comment what do we know about it. Okay, let's start. Torque, external torque which provided. Yes, we know it. Good. What else? P. P can divide it in two. It will be, you can, in this case, you can either take into consideration the direction either there or in equations. It's up to you. So I prefer to do it there. So I put, first of all, I forgot to do, I need to provide a basis. Because even there, they don't provide it to you. So it will be px equal p cosine alpha, and py will be minus p sine alpha. We should write q. Q equal to f. We can make it fq equal to ql. Also, we need to write rx, ry, ma. We don't know. After this, we need to write solution. We have one body, we need to write three equations. According to x. We can just move it in the picture or there. It helps you to not forget something. So you may say, okay, we have p there. P should be p cosine alpha. We have plus rx. We have fq. That's it. We know this guy. Hence, we can take what also. And this guy. We can find this one. According to y, it will be py, or we can write it minus py or p sine alpha plus ry equal to 0. Again, we know this guy, we can find this one. I'm highlighting the answer as I asked you. And we need to choose a point. Do you know how do we need to choose this point?
To remove some, like
Yeah, actually, it's you can choose whatever point you like. We can choose this point. It's up to you. But it's better to drop some extra. So if you can eliminate some variables, it will be better. Actually, you just need to have an intuition where you need how to choose point. For this case, yes, it's obvious that we need to choose A. And around A, what it will be? It's the most complicated one. About about direction. It's up to you how to choose, but you need to choose it in any case correctly. I mean, if you decide that it's positive, so every rotation should be positive. Otherwise, you will see wrong result. I used to use, as we did in all the angles, counterclockwise is positive. So minus m, we know it, minus py multiplied by 2 y, py to there, perpendicular to A, plus O5 fq y. If you rotate, it will rotate counterclockwise. So assume that you need to find a perpendicular y of 5 because it should be perpendicular to this point. Plus m8 equal to 0. We know this, and this. We solve the task.
Why you had all forces on X with plus?
What again?
Why you have everything with plus?
There?
Yeah. Something should be minus.
Actually,
Then actually maybe you like assume that it is in that position, but
It will appear the same.
actually, yes, we just put minus minus, and in this case we'll receive minus there probably in the city. We'll just change the direction. Because it's like in velocity also.
So it is okay to do like this, like to...
Yes, after this you
force
just put numbers and you will receive the correct result. So it's let's call it almost ideal solution. Again, let's go. First of all, we need to find the search object. So we need to get what's how. So why do we need it? When we will in dynamics, it helps you a lot because we can solve tasks in there using when we will our research object will be the whole object. It can be only part of the object, and you need to write about it. So okay, I assume that our system consists of 5 objects. A, B is have rotational movements, these have motion plane, blah blah blah. I will consider it a whole system. I won't cover it in this way. I mean, why? Because some algorithm provides you to work with it. After this, you need to write, yes, now we know that the body fixed, but in the future we'll write it, make rotational movement, this with this movement, and so on. After this, we need to draw a picture, present the basis, and write the force analysis. Actually, it helps. In this case, you can expand something because it helps you to understand what do you have and what you do not have. I mean, I have this force, I have this force. You even can, let's say, find something, just put formulas and solve something. If you need one step. For instance, I have Fx, I mean, is friction. Okay, you can just write minus x, k, and put for instance x there. So you can write some additional info for you. Not put formulas there, but there. And when you do it, you can, okay, k I know, this I know, I need to find x. It helps you to get what you don't have. After this, in our case, you don't need to provide this, you write, I am using this approach, for instance. I decided because you will know several algorithms like Lagrangian, some other algorithm, Gavertons, and blah, blah, blah. And after this, you need to write, I decided to use this one because of this. And you just provide a solution. Yes, it looks more, I mean, bigger than you used to use when you solve the task with result. But it helps you to find mistakes. I'm sure of it because it helped me a lot when you write the full equation. And after this, it also helps you to, it helps me to get what I try to do. Because I see all forces, I can easily get, okay, for instance, you forget about Ry. I don't know why, just forget. You won't put it there. And I see, you just forget one variable. It should be, for instance, you have it there, but you forget to put it somewhere else. So it's easier to get what you're doing. Now let's go to the next task. It's your task.
Excuse me.
Yes.
Why in the end we put torque around A?
Because this.
The summation of the torque around A is equal to 0.
Yes.
Okay, but this
It's actually you can call it. This reaction, I just call it like this. Actually, you can call it whatever you like.
So when we have a reaction, when we have a torque on the...
Yes, you have reaction torque. I don't know how it's called. Reaction is still in Russian, but actually reaction torque. Yes, actually.
Net torque.
See, do you understand why reaction appears generally? Because reaction provides you to, so you have several degrees of freedom. I mean, for instance, we have, so when we fix something, we, how to say, we strict to have this degrees of freedom. For instance, if we have a pin like this, it can rotate. So in this case, we won't have a problem with torque. Why? Because it can rotate. We don't have any reaction. Of course, we're not considering friction. But it cannot move in this direction and this direction, the pin. It cannot move. So we have Rx and Ry. And to prove my words, there Rx and Ry, you will have a pin. Because it cannot move. So when we're talking about reaction like this, we are talking about linear motion. If we are talking about torque, we are talking about angular motion. For instance, this guy, it can move along the xi axis. It can rotate. So it on the one on direction, it cannot go up or down. Where we have Ry. I just like this one because I wrote N, but I prefer to write Ry in this case because it's more intuitive. Today, all our tasks so KGF, Telegram force. Do you know what is it? 10 newtons. Just you can assume that it's 10 newtons. You can find your motors. I mean, in robotics, you can find when you want to buy some motor, you can find it in Newton multiplied by meter, or in KGS multiplied by centimeter. Thanks to Henny, I just took it from Mishevsky book in English. Yes. If someone wants to solve it on whiteboard, you're welcome. Otherwise, you need to solve it on your sheet. Okay. Do you have any questions regarding the previous exercise? Nice, is it clear? Is it clear the previous task? During the heavy drawing, I will explain you our next 3 days, next 3 classes. On the Wednesday, we will solve more advanced topics. What will be? Actually, today, if I'm not mistaken, if I did it wrong, so we won't solve this task. Today, we solve all tasks when we have only one body. Easiest way. In this case, you can write only 3 equations actually. Tomorrow, Wednesday, we will solve the task when we have multiple bodies. So we will solve.
And in the exam, what tasks should be?
So, or also you will have a home task. One home task will be regarded to the multiple body or even one body. It's not. It's I actually don't need to code it. Actually, you can do it if you don't want to complete math by your own. But actually, you don't need to provide any special report. You may just take a picture of your.
Yeah. By the way, how you are going to grade the assignment, the homeworks? Just like by the solution or the codes?
I just read solution. I see your things, your thoughts, and after this, I just decided, okay, I will provide you feedback. Actually, you get it's the big home, except the big home task, which have a lot of points. I mean, this research home task about it has 20 points, and you need to solve it nicely. You need to make a really good report. All this home task is mainly for you, because otherwise, You can think, oh, I have another task to do. In this case, you need to solve home task because I'm sure of it, you don't need to prepare to the midterm. If you solve today's task and previous task from kinematics, you did it actually. You did your home task. It will be easier than your home task. My goal not to drop you. I like to drop people, but if they're not working, if you work and I can say that you work. Because you ask questions, you do something. You complain, oh, let's extend the deadline, please. Yeah, and it means that you try to do something at least. Nikita today had office hours with me about 1 hour. So I see that, no, he told me that he wants to solve this task, the second home task. Is the reason why he won't be there. Because he tried to solve it in vector form, not in geometrical form, and he had some difficulties. So he spent a minute.
Yeah.
About today.
Yeah.
You should try solving it using IC.
So
Which one?
Plot it using IC.
No, it was where the big the
With
mechanism.
triangle?
Yes.
I solved it using this, like to plot it on the
So he tried to solve it using vector form. Even kinematics. He had a problem with kinematics. So actually he asked me the question how to find the roots. Because MATLAB he using Colab, the Colab cannot provide him the right solution. He cannot find the solution. What? Because as you remember, you have two roots in solution because the intersection between two circles is two roots. So, and the problem, as I told you when I explained the three possible ways, the vector form have difficulties to show your computer. That you need to choose this precise root, not other. I had this problem, and it's the reason why I use Jacobian method to find kinematics. Actually, you will get how it works.
Also, should we take care about the weight of this rod? Or not?
Did you see the text? The weight of the rod is 2 kilograms. Or it weighs not kilograms in meters. Or it's 17. So, and you will have two home tasks. First one for this, and the third one to probably it will be easier for you to code it because it will be in 3D. It's asking 3D. So you actually won't solve it there because it just will be routine task. You just need to think in 3D, not in 2D. You just expand your horizons. It's also from Jablonski, so it's not so difficult. You can find solutions from, internet and just code it. It will be easier for you to receive vectors correctly if you code it. It's the reason why. In this case, the first task, if I were you, I won't code because it's just to display plain case. And the other one, I will code. And on Monday, you will have a midterm. I'll ask our professor, did he agree to do it on a lesson or a lab? Despite it, you won't have lab on Monday.
Great.
So we will have a rest. On Wednesday, we will probably, I'm still thinking, because in one case we can start to solve dynamics, or we can cover, to find mistakes from your midterm. We can discuss about research home task, because you already should provide the solution. We will discuss how to solve it. Maybe we will cover some interesting solutions. Because, for instance, Daniel found the fancier solution. At least according to his work. Yes.
It looks cool, but like I don't understand what the fuck is going on.
So
I need somebody to
so
explain.
either we will solve dynamics, but it seems I think we have enough time, and probably also present you the next home task. The final big home task. The problem is that you cannot start to solve it now because you don't have enough. Actually, we didn't start. We haven't started dynamics yet.
But like we had only half a lecture about dynamics.
Yes, but I mean that I can provide the task because you can start to at least do something. This is about yo-yo. Yo-yo is
We saw.
what?
You published it.
Where? Yes. But I find mistake.
Nothing that goes into the internet gets
Guess who managed to know this? Not me, actually.
So actually, it will be your task. I was planning how to do what to do. Where can you find video, and so on. So you may guess that next week will be relaxed week. because you also have midterms for the two tasks. I mean, so I mean that you won't have home, on next week you won't have home task. So whole
But,
next
but,
week.
but, but, but we
you
should, but we should meet the big report on next week.
You need on this
Oh,
week.
this week.
This week.
Week, yes.
Oh,
I mean, next week you won't have home task.
Ah,
So on Monday or on Wednesday, so you can have say, you can think about other tasks. After this, we'll start dynamics, and it won't be easy. Be ready.
How broad the description of the big home task should be to get like,
I don't need a lot of water.
because like yeah, okay, not water, but like to compare, I have collab, like markdown cell, like my name, solution description, brute force, like two sentences about the algorithm pseudocode and the code.
Okay, I
Is
see,
it enough?
I see. Open your PDF and start to read.
It's not PDF. It's a
Okay,
collab.
open your collab because actually some guys from the previous year provide me markdown, online markdown. But in this case, you can put GIFs, you can put some figures and so on. I mean, you are using different, how to say, they use markdown online, you're using,
I mean, like,
some of them use Placket.
you speaking about it, and I'm feeling I like missed something because what I did, I like put one cell, like name,
I can
solution
show
description,
heading.
pseudocode,
How is this?
the code itself. Is it enough?
I will show you the previous.
Can you look at my submission and say is it enough?
I don't see force. You didn't provide me force analysis.
actually, there is.
Where?
It's changed to-
Write me explicitly all forces. Which you need. While you're doing it, так, It's really annoying when you touch this wire, all crashes. Okay. Okay, can you moves? Okay. So no, I'm talking. What problem do you have there?
So, yeah, so we have, so we have the actions. The actions.
I see only one reaction, second reaction, where are the other reactions there?
What do you?
Do you remember what I wrote? Force analysis.
Okay.
By
Then
words.
you force analysis. After this, I put all forces which we have.
Actually, like I'm putting them here on like.
I put it also there and there. I know this looks annoying, but it will help you in future if you used to work with it. Okay, I'm opening the solution from the previous year. Have a dip. Okay, I put one guy 10 out of 10. Where
Only one guy.
Yes, 10 out of 10, only one. Or two.
Красава. I see Красава Yuri.
Ah, yeah. I wrote Красава, yes, okay. Let's open it.
Сейчас будет какая-то огромная херня.
So,
Markdown in Python.
so he provided Python and this one. After this, I'm opening where it is. Markdown, yes.
And see, my submission just to hit all the color.
After this, I just copy paste it, put it there. Like this.
Oh, nice submission. Richard 20. You should like it should be 10, and the weekly homework should like weight more. Like you increase for difficulty on time spent.
What is this? No, I'm not open. The... yeah. So he explained me that there is a cat. Yeah, the cat want to pass trajectory without drifting as fast as possible. And he explained the task.
This is the assignment, the big assignment.
А зачем?
Yes.
Зачем explainить task? Ты же и так знаешь task.
Because, as you remember, he reformulated, and you tried to reformulate it as you want to solve optimization task.
Я ничего не реформулирую, я как прочитал, так и решил.
Originally, you try to reformulate it, and you think how to formulate, because I provide you in text task, and you can reformulate it in your terms. He explained me, okay,
I'm
we have this
pretty
equation,
satisfied.
this trajectory. He presented me a trajectory. I can read it. Cat speed limited to this, it's this, and this. After this, I ask you, please provide me the tools which you are using. Python, HAMD, Mark Editor, HTML, but from alpha to taking derivatives, LaTeX for pretty formulae. After this, he saw solution. Best case, this case, blah blah blah. He provide me equations. Don't forget about legend. He put legend there. He put
Он начал с максимальной скоростью.
after this blah blah blah. Real case. So that he put some figures because he liked it. He liked cats. So he put some acceleration.
Ясно, откуда ты.
So boom boom boom. Actually, I found two people received 10. After this, he provided me, wrote for the real case, graphs of time. Actually, yes, he did as you may see, he didn't stop. So he
У
did,
меня то же
yeah,
самое там.
yes, blah 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 blah. So as you may see, he didn't finish as you.
Ну вот у меня такой же точно.
Yes, I know. So you deserve a grade. That's it.
Who put the last one?
What, this one?
Yeah.
It's Dasha from the fourth year, bachelor student. She made this picture for him. Yes. So for him. So it's very nice, not big, because several people provide me bigger. He put. Actually, I can read it and understand what's going on here.
You can also read mine.
If I can do it,
10 times less.
if I can, okay. I just provided the really nice report, which I really like. He spent about, he told me he spent 3 days to solve all this task and make this report. I just explain you how you can provide the solution. That's it. If you take the worst results,
А, ну ты кому-то 9,9 поставил.
it's about because of legends. I told you that I will decrease the score. So is another. So boom boom, boom 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 boom. That's it.
Wait. How much is it?
7.
Because the legends.
No, because of Vika.
What?
If the guy cannot provide me a real nice result, actually I need to take into consideration that you're smart, you're too smart, because you are studying this course a second time. So if you are not so smart, you cannot do. So I also try to consider that your, let's say, potential. So she deserves 7 because he asked me about this task 3 times, or two times. Vika. He goes to me and asks me, Oleg, how to solve this task? Yes, surely. She asked me 2 times how to solve the task, found some questions, and so on. It's the reason why she received 7.
Instead of 10.
Yes.
So
Because,
we shouldn't ask you. This is how it's going in
Oh
teaching,
shit!
right?
no. You can solve it without any questions. Actually, they ask me questions.
Oh shit.
Oh shit! So it
I
doesn't,
have
it
one
doesn't
more
work like
time
this, you
left.
know? Teaching stuff. You know?
You think like this.
No, everyone thinks like this. That's why there is office hour. There is questions. There's
So office hours, yes. If I see that people try to handle how to solve the task,
yeah. So 7 because you came to the office hours.
okay. Do you want to have D grade or A grade?
So it is now A grade or D grade.
It's now about degrade.
Yeah, I think so.
If the person can receive max C grade, in this case, if he tried to at least do something to receive not D, I will help him. If, for instance, Danny comes to me and asks questions, he won't receive anything. He won't receive any points about it, extra points, because he can do the job 10 out of 10 without my help. You can do it too.
Okay, with the first. Okay, but I don't see the connection that you have like to decrease the grade because someone asked you about it.
I'm not decrease the grade. I'm increasing on the grade. Okay, let's.
Yeah. Okay. So this is the forces that we have. In C we have reactions X and Y. In B we have X and Y also. We have in A we have also reaction. In AB center of mass we have F, the weight. That's the weight.
How many, how many variables do you have?
How many values? We don't know anything of the reactions. We only know this. That's
So
why
we don't know 6 variables.
Yeah.
Okay.
So also we can construct other equations from tools from them, like points. So first equation we don't know anything about. This is the same. And here, yeah, I think I'm missing some. I'm missing one of the.
So actually, you can just go through this and get what it means.
Yeah, no. And then we, I think, is it correct until now or not?
What do you think, others?
I don't know, it's data.
So it's correct?
Let's see, let's see.
Ты нормально. Настя там одевает от группы. Да?
А, це теж надо. А я как-то забил на це.
Да, не вот about you.
Почему только 3 нет, 4 нет? Looks fair. Looks fair.
Which R or L?
Huh?
Because I didn't hear like the last letter R or L.
Looks fair.
Fair.
Like справедливо.
Справедливо, you know?
I know it's mechanical. Starting to solve this.
Вот, все, что я сделал. Collab. Написано Tools Used. Solution Description. Прям как ты написал в этой. Псевдокод. Можно типа постараться много прочитать. Вот настоящий код. Его, кстати, он более понятный, чем псевдокод. Вот, эта ячейка считает решение. Это все принтит. Total time. Как бы proof, что они учители. И рисуночки. А? Все? И что-то еще надо. Я не понимаю просто, зачем делать Markdown, вот это вот все. Вот, у Юры такой же график был Y, короче, можешь мне говорить.
RBY.
Можно видеть, что сделать он будет.
Я знаю, я помню.
RX and Y.
Пожалуйста, разогнались, нажали, потом тормознули, точнее, потом разогнались до максимума, тормознули, разгоняйте снова на максимуме, тормознули. Ну, нормально, не обязательно было.
Ну, по-хорошему, это график был бы нормально.
В
I
смысле,
think
на
we have to get
Он вроде
two
ну ладно
rounds
сделал.
Все, сейчас не...
and get motivation to get the
Ну, мы уже обсуждали, как решить.
Because we have to
Владимир,
What?
я видел, что ты понимаешь, что ты сделал.
Я просто пишешь
Yeah, but we can calculate one of the like also because it is equilibrium state, so any torque of around any point will be zero. Right? So if we got the torque around T also we have zero and we will have more equations to cover the number of unknowns. We have 2, 4, 6, and that's 6. So we need 6 equations.
Is it logically possible to take the torque around C?
Yes. If you consider like it's a string, right?
It's a string, yes.
Yes, string.
Actually, well, it will produce some reaction here, I guess.
Yeah, the problem is that you don't have 6 variables.
We have 5.
No, it's okay. You have two reactions here, you can write
It's the same reaction.
The same reaction.
Why same?
I mean,
Depends on angle.
you have T there.
Yeah, yeah.
Yeah.
T here.
Yes, it is there. Like this.
Yeah.
Because we can put force along the line.
Okay.
So, do you think that should be different for
No, you can write. I mean, you
Oh,
can
yeah.
write the point B. You will have T like on C and.
Yeah, they have two forces.
So you are saying that we have the tension here, right? And this tension will
Produce
be
reaction.
decomposed like this and like this, right? And like this, and the reaction of this point would be downwards, right? So the tension will be like equilibrium because of this reaction, only this reaction. You're saying this.
It seems so, yes. Actually, I need to check the answer.
I mean, just for me, it doesn't seem logical to take the torque around point C.
Yeah, not around C, but around B.
Around B. Around B. Yeah, around B, yeah. It makes sense.
Around C, you will get, I guess, degenerate equation, which will not give you the reduced to itself.
Yeah, maybe we can take it around B and around A.
Кто-то звонит, мне спрашивает. Вы пометили, как спам первый раз на такой номер?
So just to be clear and also ask you about something. So if we have office hours with you to discuss the question, the answers of the question that we are going to submit. So our grades are going to
No.
downgrade or not? No? Okay.
I told you, I am not downgrading grades at all. I can only increase if I see that you work hard. That's it. I'm not downgrading any grade. Very much.
Pure one, 2, 4. Infinite. Who did that?
Actually, I didn't ever know. That's the most disappointing.
Interesting. This is the solution. Penny.
We have around x go down. So we have yeah,
And around A.
forces x, forces y, for torque around a, and
Что такое S? Ну, посмотри справа.
this.
XY, it's a reaction around it. So it's your Rx, Ri, the same. T cosine, T sine. It's obvious. You did the same, yes?
Yeah, exactly the same.
Yes. Torque around
Around
A.
Yeah, also around.
Yes. After this, we told me that from the third one, we can find T.
Okay. Ah, so there are some.
Because G, AB, 0, T sine AB.
Okay.
Probably also should be. So after this, you need to put it in a second and a third. So actually, you need to write on the equation, yes. You don't need this. Because you, as I told you, consider on the T. Do you get why we consider only T there? We don't have Rx or Y there, as I told you. Did you get? Because when you have a string, each string have, how to say, yes, each string has hinge, because you need to fix it somehow. So it's the reason why we have only T there. So I just decided to check because I told you that I'm wrong, and I decided to check that I'm correct. That's it. So actually, it's the best case. I can send you a link about from Mishers book. I mean, it contains all solutions. I provide you from English books or from English book, and it have different numbers. But you can open Russian book, find the same exactly the same picture, find the task, and just open the solution. Actually, just go Google Решебник Mещерский, and that's it. Yes, it seems that you can do it at home. Yes, but in this case, we can discuss. Is the reason why I don't see any problems to use solutions during the class, because if I told you, if you want to learn something, it's better to try to solve by yourself, provide some hypotheses. After this, open the solution, check that what was wrong, what was right, and after this, you can increase your knowledge. Yes, it's reinforcement learning. Actually, it is. You like neural network in your brain, train it. Okay. Actually, I did the same when I was when I taught this course previous year. Because now I need to spend only 4 or 5 hours to prepare. I need to put slides, I need to choose the task. That's it. But previously, I go to Malaletov, my supervisor. We spent about 2 or 3 hours to solve tasks.
And he has this time.
Because he's my supervisor. He has to spend the time with it. Because I'm TA.
He has spent his time on your thesis, like helping you with the thesis.
I'm also his TA.
Ah, he used to teach.
Yes, actually my supervisor made this course.
Why Paletkin?
Do you want formal or informal information?
Both.
Internal, if you want.
The problem is that Maletov, how to say, he's not a professor in Innopolis. He had a profession in Bittrex. I mean, officially his job is professor.
Last year, right?
He taught me Russian.
He's speaking.
Not so well. He is learning now.
Paletkin also.
Actually, it's so Paletkin. I don't know about Paletkin, but it's the reason. So I don't know other reasons, but probably he's increasing his English, and I hope next year he will be a lecturer on the next course. No. I mean next semester, because we have a course mechanics and machines, which this course you can find not in internet, but actually it's not so unique course. Yes, I try to put coding and so on. It's not so unique. We use books, but the next course we made it by ourselves. Yes, so it's a unique course, and we will write with him not a sketchbook. I mean PDF book, and we will sell it to others. So
English, please.
what?
It's gonna be
In English, of course.
Yes.
Because it will be in English because it will be. Is the what's the main problem for this course? Because I need to translate book, I need to translate, or I need to find some information in English. So we have two goals. We want to make this kind of book for theoretical mechanics, and actually now I'm solving these tasks. One goal translated to English. I mean my solutions, and it will be provided to you. I mean for two next generations. We want to make a methodичка, I don't know how to do it in English. Methodичка. So, sketchbook, what? Methodology book, let's call that this. In Russian called methodичка.
I believe like the main.
So you open it, you may see not my ugly, yes, handwriting.
I believe like the main problem was when the course was created. Like if you just depended on an English resource, that's it.
The problem I explained that the main
Yeah,
problem
yeah,
that
I
only
understand.
several areas domains in the world where Russians are very good. One of them was theoretical mechanics.
А прошу говорить.
Чего?
Unofficial. Why Paletkin?
Just because they decide, so, how to say, an official. Someone should teach this course.
Yes.
So,
Paletkin don't want.
no, actually, he helps me to increase this course because Paletkin didn't provide a lot of information which I tried to cover.
Paletkin provides some interesting information, I would say.
I know about that force is nothing.
Torque doesn't produce force, and vector of that force is not collinear with acceleration. Like Nadia just found.
Okay, guys,
We're creating a BY.
video. Today we have two videos about very interesting stuff. Иди нахуй просто. I am. Okay.
By you are
Continue.
developable mechanisms.
We need to edit the video. Why? No, the recording.
It's okay.
What do you mean?
You will need to edit the recording.
So what we're creating at BYU are developable mechanisms that make it possible to make complex machines that integrate onto surfaces to be very compact, but now can deploy and do complex things.
A developable mechanism can reside in a curved surface. So it's kind of hidden in there. And then when I actuate it, boom, it comes out of the surface. So one example might be things that reside on Iron Man's suit. For instance, on his arm, there's some kind of covering there. That's a developable surface. And if there's a mechanism that comes out of that, does something cool, comes back in, that's a developable mechanism.
So there are a lot of industries that this can apply to, one of which is surgical equipment. If this was to scale, it'd be a small, minimally invasive surgical device. And as it goes in, you have two different components that will unfold off of it, one of which could be a camera or a light, which still leaves this center tube hollow for a different device, such as these forceps, to now come in and do the operation.
This technology shows the most promise in the medical industry and the space industry. So for the space industry, you want it to be compact for launch, and then once it gets into space, it can deploy. This may be a rocket or a missile and have this fairly complex mechanism that just morphs and transforms off of that surface. Here's a wheel that's rolling on a Mars rover. We hit some obstacle, we deploy that, becomes a crawling mechanism that can crawl over those obstacles. We're also beginning to look at things like deployable drones.
So I want to have the drone be nice and compact when I carry it around. So what's fun here is it's deployed, right? Then it can go back into the surface.
We were doing work in origami-based engineering, and as part of that, we moved into curved folds. The mathematics revealed we can implant machines on there that will have these complex functions and morph out of those surfaces.
We usually design the mechanism independent of its home. So the idea of using a curved surface as the kind of home for a mechanism, that's revolutionary because we don't tend to think about mechanisms in this way.
Suddenly we could do really complex things that no one's ever been able to do before.
What do you mean? we get is about kinematics which I try to solve using real applications.
Почему понятно?
Потому что кто-то должен вести. Вот и все. Малолетов нас следит за нами. Ну, то есть я ему докладываю, что мы делаем. Да ладно.
Вы слышали тогда его этот? Please tell Малолетов to tell Poletkin, like, to, так сказать, порешать сам вопросики.
About what?
About Newton's law. Why he tells us what net force is not collinear with acceleration? Что?
Okay. Okay, let's discuss how to solve this task. What's the main problem there? Any? Actually, nice job there.
Спасибо.
Молодец. Actually, it's the beam with some force, but the main problem with there that we have reaction not in one place but in two places.
Oh,
No, we don't have enough.
what is the problem?
No worry.
What?
I mean,
We used to have one reaction, Rx and Y. In this case, we have Rx or Y, Rx or Y.
no, too many unknowns.
Not actually too many, because this reaction should be the x-axis of reaction should be the same. Otherwise, it won't work.
Ah, это груз типа вещи.
Yes.
I think still, like, we
We'll receive.
three equations just like this, and it will be solved. I
You
guess.
cannot, in any case, because we have only one body.
Ah, actually easy. You can use the third form of the static equation of how it calls the no motion equation. How it's called? Equilibrium condition. The third form of equilibrium condition. Torque and 3 points. You can like in point C, in point A, and point B. Super easy.
Yeah. Alright. That's because you, as I told you, you can provide three equations. I mean,
You don't even
one
need forces.
x, y, and torque.
Torque, yeah.
Yes, but we can make also the free torques. I mean, free torques points. We can provide three unique equations. I mean, we can find only three variables in one body. If we have more bodies, I mean real bodies, not a second for the body, we can receive more. So when we have multiple bodies, we can find 6 or more variables. In this case, only 3. Yes, yeah, you're right. I recommend you to solve this task at home. It will be your home task at home. Actually, you just need to sit, spend 1 hour, and I think you will solve it even faster. And you have a result, because it might help you tomorrow. So, the first task, it's up to you. So I put 2 tasks, it's also interesting. If you, actually it might help you with your midterm. So nothing till Wednesday, or we can say 3 and 4 tasks. So that's it. Penny running away as usual.
I tried to finish the homework 3 because yesterday I just make a quick draft for it. I couldn't finish it.
We discussed it.
Okay.
Да. О, может, объяснить? Где-то всякое.